Hi everyone, Lou here with video number 3 of 4 in the FRC Robot A to Z series. Let's look at something that we don't always use every year, but that's pneumatics. So pneumatics refers to, of course, a system that uses air to provide power. And so let's go through the back of the robot. So we go back to this pneumatic control module that I mentioned earlier. Okay, so its job is to send signals to solenoids. So how do you control air? Okay, you can either turn on the air or turn off the air, and the air travels through these tubes. Okay, and to control the airflow through these tubes, we use these solenoids. Now, solenoids comes in different shapes and sizes. These particular ones are made by Fast Tech. Let me see if I can get a good picture here. And you'll see that there's what, 1, 2, 3, 4, 5 of them, I think. Yeah, there's 5 of them sitting side by side. They're actually sitting on the manifold, this one. So we feed air into this manifold, and it comes. And then we give it control signals through the VRM. The pneumatic module. So the pneumatic module gets its control signals from the same CAN bus that we talked about earlier. And then in response to the commands from the CAN bus, it sends voltages to these black and red wires, which control coils inside each of these individual solenoids, which then allow to turn on and turn off the airflow from the master supply to either of these outputs. Now we try and color code the tubes as much as we can. So in this case, we see some red ones and some white ones.
Well, that was a bit of a jumbled mess, wasn't it? So let's recap. Your program sends instructions for the pneumatic system over the CAN bus. These commands reach the PCM, which in turn uses the solenoids to manage the airflow between the manifold and the individual cylinders via the tubing. Got it? Our pneumatic system sits low in the robot and can be hard to see. This black cylinder and another one sitting just behind it are storage tanks, also known as accumulators. They hold compressed air from the compressor. In our use, this is limited to 120 pounds per square inch, or PSI.
Here is our compressor. Remember how I said everything was down below the robot, which is why it's a little hard to see. This is a compressor right here. Okay. And the output of the compressor is right here. And here's a safety valve so that if there's too much pressure built up, it vents out. The air then comes out through this yellow tube. Okay. It goes here. Let me see if I can get there. Okay. This is a pressure switch. Okay, so it's a sensor basically that says, hey, you know what? I've reached a certain pressure. Now, what is that threshold? That threshold is 120. Okay, so this switch will trip a little bit before, at or close to 120. 120 is 120 pounds per square inch is the most amount of pressure we're allowed to use on what we call the high pressure side. And these two wires go back to that pneumatic control module, and through that module, it will shut off the compressor automatically. Okay, so this happens without any intervention from the software, which is kind of nice because this way, if you have a bug in your software and you don't want to have a runaway compressor that keeps charging and charging and charging. The output of this switch goes through, comes here, or one of the output legs comes here, and we can see the high pressure reading right here. It's a little bit, now the lighting isn't the best here. This is a little better. Okay, so this is the high pressure side. And then it goes to a pressure reducer, which is this guy here. Now there's a knob here that I can use to dial the pressure I want. So high pressure goes into the reducer. I turn this knob until I get the pressure that I want, on this dial, which in our case is going to be no more than 60 pounds per square inch, because that's the most that we're allowed, 60 pounds, on the low pressure side. And then the output from the low pressure side is this blue line, and this blue line goes into right here our manifold, which then goes to our 5 solenoids. Okay. Oh, and I should point out that back here, the output from this yellow output also goes back that way, which is towards the storage tanks. So that is the pneumatic system, the control system.
No, it isn't. The item to the right of my finger with the red handle is a venting valve. The label to its right says emergency air release, although it's partially covered by a zip tie. The item pictured is similar to, but not identical to, the one on our robot. Turning the handle allows air in the tanks to vent outside. This is important for safety reasons, as it removes pressurized air when the robot is not on the competition field. Hint, remember to close this valve before starting a match.
Now the air coming out of the solenoids, the 5 that are back there, let's see if I can find, there we go. Right, so remember those 5? The outputs from those, which is the white and the red tubes, they go to individual cylinders to make them do stuff. So what you see here is actually a cylinder. In this case, it's extended. The cylinder goes that way. Let me see if I can get a better view. So here's a cylinder. This particular one, I believe, it has a 12-inch reach, a 12-inch throw, or maybe longer. I forgot. Sorry. And there's tubing on one side and tubing on the other side. So one side pushes and one side pulls. Obviously, so if air goes through here, it's going to push the tube that way. If you put air in through that side, the air goes the tube goes the other way. And when I say the tube, I mean the cylinder is going to push this rod, the one that I'm holding here. So this whole thing moves forwards and backwards like so. So as this rod comes in and out of that cylinder, it's making this whole mechanism go down or come back up. Okay? Now obviously if air is going in once in one direction, the other side has to let the air out. So you have to be sure that you control the airflow so that you're not putting air in one direction and not letting air out the other side. So we have some other pneumatic pistons in this on this robot. Here's another one. This one makes this mechanism go up and down. And there's the piston right there for it. So I think that covers pneumatics. I want to go over a little bit on terminology that's commonly used, words that you're going to hear a lot.
An FRC challenge typically has one or more game pieces. This is last year's game piece, a foam ball about 7 inches in diameter. Game pieces come in all sizes and shapes. The term intake is used to describe a mechanism that handles a game piece from outside the robot to in or on the robot. The game piece usually starts out on the ground, as in our case here, but it could also come from a human player station. Climbers have become increasingly popular. They are mechanisms that allow the robot to lift itself some required distance and stay there until some game condition is met. A shooter is a mechanism that can propel a game piece some distance, usually at a target. They often play an important role during the game's autonomous period and may be guided by vision or other navigation systems. Our example robot has a low shooter on the rear of the robot. Most challenges require robots to have bumpers. The specifications for bumpers are very precise and they must be constructed accordingly. Inside the bumpers are 2.5-inch pool noodles backed by 3/4-inch plywood. Bumpers must be removable. Teams must provide separate red and blue bumpers or one reversible bumper. The pit area in a competition is where teams leave their robots when they are not competing or practicing. A team's pit is also where changes and repairs are made in between matches. The pit crew are the team members tasked with doing whatever is necessary in the pit. Pits range in size from 8x8 to 10x10. At a competition, 4 or 5 people make up the drive team. These are the people who go onto the field of play with the robot and actually compete. While the rules change from year to year, there's usually a driver, an operator, a coach, a human player, and a technician. Be sure to read the documentation carefully so you know each person's do's and don'ts. To control the robot, the drive team uses the driver station. The driver station consists of a Windows computer, usually a laptop, along with one or more controllers. The controllers may be joysticks or gamepads, but must connect to the computer via USB. At a competition, a wired network interface is required to connect to the field management system. The driver and operator are usually the only ones who touch the driver station during a match. The coach is prohibited from touching any of the controls. This concludes part 3 of this video series. Remember to jot down your questions for a later Q&A.